Joseph Gamil, and today we are going to compare and contrast some terms that are used interchangeably in elementary and high school. Let's start this off with scalar and vector quantities. So scalar quantities have a size or magnitude only and need no other information to specify them. 10 centimeters, 50 seconds, 7 liters, and 3 kilograms are some examples of scalar quantities. Vector quantities, on the other hand, have both size or magnitude and direction, called the line of action of the quantity. A velocity of 50 km per hour due east, an acceleration of 9.8 meter per second squared vertically downwards, and a force of 15 Newton and an angle of 30 degrees are all examples of vector quantities. As easy as that. The next term we are going to compare and contrast are distance and displacement. So distance is a scalar quantity that refers to how much ground an object has covered during its motion. Displacement, on the other hand, is a vector quantity that refers to how far out of place an object is. It is the overall change in position of the object.
To understand more, consider the motion depicted in the diagram. A physics teacher walks 4 meters east, 2 meters south, 4 meters west, and finally, 2 meters north.
Even though the physics teacher has walked a total distance of 12 meters, her displacement is 0 meters. During the course of her motion, she has covered 12 meters of ground, or distance of 12 meters. Yet, when she finished walking, she is not out of place. There is no displacement for her motion. Or in short, displacement is equal to 0 meters. Displacement being the vector quantity must give attention to directions. The 4 meter east cancels the 4 meters west, and the 2 meters south cancels the 2 meters north. Vector quantities such as displacement are direction aware. Scalar quantities, such as distance, are ignorant of direction. In determining overall distance traveled by the physics teacher, the various directions of motion can be ignored.
Now, consider another example. The diagram shows the position of a cross-country skier at various times. Each of the indicated times the skier turns around and reverses the direction of travel. In other words, the skier moves from A to B of 180 meters, B to C of 140 meters, and C to D of 100 meters. The distance is simply the sum of 180 meters, 140 meters, and 100 meters, which is 420 meters. On the other hand, the displacement is 140 meter rightward, since it is the object's overall change in position. Still doesn't get it? As a final example, consider a football coach pacing back and forth along the sidelines. This diagram shows several of the coach's position at various times. At each marked position, the coach makes U-turn and move in opposite direction. In other words, the coach moves from position A to B, 35 yards, B to C of 20 yards, and C to D of 40 yards. The coach covers a distance of 95 yards, which is simply the sum of 35 yards, 20 yards, and 40 yards. Whereas the displacement is 55 yards left, since again, it is the object's overall change in position. The next term to be differentiated are speed and velocity. The best way to start examining the difference between speed and velocity is to look at your car's or motorcycle speedometer. The next time you're in your car on the highway, just do that. What does it say? I'm going to assume that you always obey the speed limit. So, if the speed limit is 65 miles per hour, your speedometer should read 65 miles per hour. This means that if you drive for 65 miles, it will take you an hour.
It doesn't matter where you're driving to, how many turns the road takes, or if you're in a big circular track. Speed is only concerned with how much ground you've covered in the time you've been driving. To put an official definition on it, speed is how much distance is covered over a specific period of time. Regardless of a direction traveled, since there is no directional component, speed must be scalar quantity. Speed is a scalar quantity. So you can probably guess that speed has corresponding vector quantity that combines how fast an object is traveling and its direction of travel. This vector quantity is velocity, defined as the rate at which an object changes position. Remember that in physics, a change in position from its starting point to its end point is an object's displacement. The exact route doesn't matter here, only the direct distance from the start to finish. Displacement always has both magnitude and a direction.
In physics, you can calculate average speed by taking the total distance traveled and dividing it by the total time required to travel that distance. Average speed is equal to total distance over time. So, if we know Jamie Johnson drove 500 miles, and I tell you it took 3.14 hours, we can calculate his average speed. Average speed is equal to 500 miles over 3.14 hours, which is equal to 159 miles per hour. To illustrate velocity, let's go back to Daytona. We calculated Jamie Johnson's average speed, but what about his average velocity? Daytona Speedway is shaped as seen in the figure. The point on the track where the car serves as both the starting line and the finish line. If we trace Jamie's path along the track for one lap, he starts and ends at the same position, making his total displacement 0. Even though he drives many laps and covers 500 miles, he always starts and ends at the same point, making his total displacement for the entire race 0. To calculate this, average velocity is equal to 0 miles over 3.14 hours, which is equal to 0 miles per hour.
As you can see, his speed was 159 miles per hour, but his velocity was 0 miles per hour. The last term we are going to define for today is acceleration. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity. Sports announcers will occasionally say that a person is accelerating if he or she is moving fast. Yet, acceleration has nothing to do with going fast. A person can be moving very fast and still not be accelerating. Acceleration has to do with changing how fast an object is moving.
Example: these data are representative of northward moving accelerating object. The velocity is changing over the course of time. In fact, the velocity is changing by a constant amount of 10 meters per second. Anytime an object's velocity is changing, the object is said to be accelerating. Hence, it has an acceleration.
And that would be all for today. Thank you so much for watching.